Section 4.7, quadratic formula. This is all review. I'm sure some of you might actually know the song to this. I do not know the song, but I'm sure one of you will probably sing it for me tomorrow. So here's the quadratic formula. You have to know this right here. And by have to know, you have to know where these numbers are coming from. So it's always in standard form. A is always in front of the x squared, B is always in front of the x, and C is always the number by itself. You have to be careful though, because if it says subtraction, that would be like a negative number. So I have opposite B plus or minus the square root of B squared minus 4AC, all divided by 2A. So I want to know what are the solutions to the quadratic formula. First thing you should do is set this equal to 0, because solutions are still finding the zeros of the function. So if I subtract 0, I have 2x squared minus x minus 4 equals 0. So when I look at this problem, my a would be equal to 2, b is equal to negative 1, and c would be equal to negative 4. So now I plug it into the quadratic formula. It looks like this. A couple of things here. First, when you have this right here, this is opposite b. So I wrote my opposite sign, and my b is negative 1. So this would become plus plus. You should always make sure to put this in parentheses. Whatever numbers you are plugging in for each variable, put in parentheses. Now it's up to simplifying. So this simplified first be 1. When I have plus or minus, I'm going to leave my number in square root, and I would simplify just this part right here, the number that's underneath the square root. And if you simplify that, that would be 33. And on bottom, I would have 4. Now, I can't simplify 33 any farther because there's no perfect squares that go into the square root of 33. So one thing, I could leave my answer like this, or you can leave your answer like this, plus or minus in between, square root of 33 over 4. I would accept either one. However, when you're writing it like this, sometimes it is easier to see where you can reduce your fraction. But again, I would accept either answer as long as it's in simplified form. Here you should pause the video, find your a, b, and c, and plug it into the quadratic formula. So that would be your a, b, and c. And if I were to simplify now, that is what it would look like. Now, I can simplify this even further because 36 is a perfect square. So this would actually look like negative 6 plus or minus square root of 36 is 6 divided by 2. Now here is where you have to keep on going because you have your plus or minus. So I'm going to set out two different equations. I could have my negative 6 plus 6 divided by 2. I could also have my negative 6 minus my 6 divided by 2, because you should still get two answers. So if you simplify both of these equations, this would be like 0 over 2, which is equal to 0. You simplify the second one, this would be like negative 12 over 2, which is equal to negative 6. So my two answers here would be negative 6 and 0. Those would be the zeros of my function. Right now I'm going to pause the video and I want you to attempt both problems by yourself. Thank you. So first, the first problem. If I plugged everything in right here, I would get this number right here to cancel out 0. Now, the square root of 0 is just going to be 0. So I could write out two equations, negative 4 plus 0 divided by 2 and negative 4 minus 0 divided by 2. But either way, we would end up with negative 4 over 2. So you only have one answer here because this number right here, again, is 0. Now the second one, plug everything in and I simplified. You can keep on simplifying the square root of 28 because I could rewrite square root of 28 to be the square root of 4 and the square root of 7. Now the square root of 4 is 2, so if I rewrite this top one, I have negative 4 plus or minus 2 square root 7 over 2. Now this is where it might be helpful to write your answer in two separate terms. So I could have my negative 4 divided by 2 plus or minus 2 square root 7 divided by 2. Because now when I look at this, it might be easier for you to see that I can simplify. Negative 4 divided by 2 would be equal to negative 2. And I still have my plus or minus right here. And then this right here would cancel each other out. 2 over 2 would just leave me with square root 7. So this right here would be my final answer here. So if you can, once you get simplified this number, If you can simplify it and take out any perfect squares, you should do so. Now, one reason I always say simplify underneath the square root first is because that is your discriminant. Discriminant is the number that will tell you how many solutions you have. Because when you find the discriminant, either you have two real solutions, meaning if you were to graph the equation, the quadratic would go through the x-axis, because this right here would be like your zeros. Or you could have one real solution. This would be like the last problem we had. If you ever have a square root of 0, that means the vertex lies on the x-axis. Or you have no real solutions, meaning that the quadratic is either above the x-axis or below the x-axis. Again, the discriminant is underneath your square root. So it says, what is the number of real solutions that you have? So, first thing, when I'm asking a question about solutions, I'm just dealing with my discriminant, which is my b squared minus 4ac, because that will tell me how many solutions I have. I'm looking at this problem. A is equal to -2, b is equal to -3, and c is equal to 5. So if I plug in all those numbers, this would be -3 squared minus 4 times my a is -2 times 5, which would be equal to 49. Now this is a positive number. Since this is a positive number, that would be that I have two real solutions. So all I would need for this problem is my answer right here and then my work up above. So use that discriminant to help you find out what the answer would be here by yourself. For the first one, you get a negative number, so there are no real solutions. The second one, it's a positive number, so that'd be two real solutions. And that is all I have for you for today. Have a great, grand, wonderful day.